before we move on to a new type of form of a quadratic function, I just want to do a little review. You should be at the point where if I give you this, or you could see it like instead of y, I put f of x for function. Okay, give you one, and you should be able to graph it. From the graph, you can then state a whole bunch of properties. But you don't necessarily need a graph to state the properties. What are all the different types of properties that you have been asked to state? Give me one. Domain and range. Vertex. Axis of symmetry. Max min value. Good. You got to be a bit more specific.
No, I know the word is.
What about the x-intercepts? Did I ask you to find them? You were asked how many x-intercepts. You were not asked to find them. But you are asked to find the y-intercept. I think that's pretty much everything. Okay. It is possible to answer all of these characteristics without graphing. Okay. Which is why in the first questions of exercise 2.3, I said without graphing, state all these properties. Okay. It doesn't mean, and I should clarify that, because I'm not going to give you a question where I give you this and I say, okay, you can't graph it, but you got to state all these. If you're stuck, okay, sketch a graph. You don't necessarily have to be 100% accurate. Like when we were finding the x-intercepts, we were just kind of roughly sketching where the parabola was, right? We weren't doing it on a grid. Okay, that will be sufficient. So for example, like it may help you here. Say, okay, I'm just going to do a rough sketch, because then that's going to help me answer these questions. So a rough sketch would be, well, where would the vertex be? Because you always start with the vertex. Yeah, I'm going to go down 5. 1 left, because it's plus. So 1 left, 5 down. And you may want to just write the coordinate of that point. -1, -5. Okay. The other big thing I need to know is whether it opens up or down. Why up? Because it's positive at the front, so it opens up. So it's going to look like this. Okay, so I have a pretty good idea of what it looks like. Is it a 100% accurate? No, I didn't do the 1, 1, 2, 4 or 1, 2, 2, 8 thing. You'd have to do that if I asked you to draw the graph and give you a grid. Okay, but if we're just stating the properties, we can roughly sketch it. So some of the properties we don't even need sketch. Like domain, you should know automatically. automatic. It doesn't matter what this looks like. The domain is always that. Okay? The range, however, and the axis of symmetry and the max-min value are all going to depend on the vertex. The vertex is the point we always start when we sketch the graph or draw it accurately, and it helps us answer other characteristics. So what is the vertex of this one? Let's jump straight to the vertex. -1, -5. Now, let's go to range, axis of symmetry, and max-min value. The range is what? Lowest to highest, so it goes from -5 up to positive infinity. These two characteristics you can answer from the vertex. I've explained this. What is the axis of symmetry? X equals -1, not -1. X equals -1 because you are writing the equation of a line. So if you are writing the equation of a line, you have to put the X in. Okay? And then, well, there's two things here. Max or min, and at what value? Min, still don't have it right. Min at y equals -5. Put those variable names down. Okay? Always. X-intercepts, look at the sketch. 2. Y-intercept, well, we can't really use the sketch. I mean, it looks like it's going to be around -4 or something, but we don't know for sure. This is where we use our algebra skills. To find it algebraically, we make x equal to 0. So in the original equation, y equals 2 times 0 plus 1, all squared, minus 5. This works out, if you calculated 0 plus 1 is 1, 1 squared is still 1, times 2 is 2, minus 5, it's actually -3, not -4. Okay? But you can see how you can, so know how to do this. Or I could say, I'll give you this, and I'll give you a grid, and I will say, sketch an accurate graph. That's where you've got to show me at least 5 points. Here, if you sketch it, you really only need to show one, the vertex, because everything starts from the vertex. Okay? But if I actually graph it, then you'd have to do the one. If I actually asked you to graph it, I'd have to go 1 across. How many up?
1 out. Oh, we're going to choose the 1 out.
1 out, 2 up. 2 out, 8 up. Excellent. Okay. So be familiar with that. So life's pretty easy when it's in vertex form. What if it's not? I know, you love it. Yes. There are 2 main types of forms for quadratic function. Vertex form, we've seen. Vertex form is y or f of x equals a times x minus h in parentheses all squared plus k. And we are basically able to read the properties off the equation. Standard form, it will look like this. y or f of x equals ax squared plus bx plus c. You can't read the vertex off of standard form. Okay? So that makes it more challenging to graph. However, okay, we can switch from standard form to vertex form using some algebra. We can make, if it looks like this, we can make it look like this using algebra, which is sort of the main focus of this lesson. But before we do that, quadratic functions. How do we recognize if an equation is quadratic? How do you know, like, if I just write an equation, how do you know if it's quadratic? What do you look for? Really? Look at all the examples that we've done of quadratics, graphing, stating properties. All of those equations had the same thing in it every time, somewhere, a squared. Okay? We call that the degree. The degree of a function is the highest exponent. In order to be quadratic, you need an exponent of 2 and nothing higher. If there's an exponent of 3, 4, 5, 6, whatever, not quadratic, something different. Okay? If there's just an x or just a number, not quadratic. The exponents also have to be positive numbers, positive whole numbers. You can't have negative exponents. You can't have fractions. So look at these. Tell me which ones you think would be quadratic and which ones would not. You don't necessarily have to do them in order. What about B? What's that? Well, I wouldn't concern yourself too much about it. We'll be okay. The first one is what? Yes. So, yes.
No.
Second one, no, because it's got this. That one's a little bit more, but what's making that one a little challenging? The weird exponent where the x is. Has to be a number. Okay, there's a 2 here, but if there's any other, there's no other exponents in a quadratic, is there? There could be an x term, there could be a number, but there's no other exponents. So, no. Next one? Yeah. Next one? Oh, you got to think back to grade 10. Yeah, how do you write the square root as an exponent? Do you remember? X to the, whoever said that? I thought I heard half. Did I not hear half? Okay, well then now I've just given you the answer. If you remember from grade 10, the square root of x, remember square root, we can write a little 2 there, is the same as x to the 1/2 power. You can't have that. Okay, you can't have a fraction exponent. So this one, because of this square root, would be no. Finally, the last one. Yeah, it's got a square. Yeah, it's got some parentheses there, but I mean, this is vertex form. You guys are used to seeing them like this. So yes, good. Okay, how do we go from one form to the other? It's actually pretty straightforward to go from vertex form to standard form. You just kind of have to multiply everything out and rearrange everything. Okay? It's more challenging to go from standard, or sorry, from standard form to vertex form. So let's do vertex to standard. I need to make this look like this. So I can't have any parentheses. What do you think you'd do to try and go from this form to this form? What does x minus 3 all squared mean? When you square something, what does it mean? What? It does not mean double it. Times it by itself. So isn't x minus 3 in parentheses the same as x minus 3 in parentheses times itself? Can't I multiply those? How many multiplications? You should know this. 4. Yoink, 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 yoink. That's the mathematical terms for multiplying. So x times x. X times minus 3. Minus 3 times x. And minus 3 times minus 3. Plus 9. And I still have a 7 at the end of this. So I've gotten rid of the parentheses. Now I just have to simplify it. So y equals, well, I've got an x squared. What can I do with the x's? To make? Don't overthink. Negative 6x. We're just adding them together. You guys are looking for complex multiplication. Plus 2. That's standard form. It looks like this. What's the value of a in this? The number in front of the x squared. 1, right? Because there's no number. If there's no number, we always assume it's 1. What's the number in front of the x? No, what's b in here? Good. What's c? Right, 2. So here, a would be 1, b would be negative 6, c would be 2. Okay. So it's pretty straightforward going from vertex form to standard. You just have to multiply out what's in the parentheses, simplify, and make sure everything's in the right order. That's pretty straightforward. How about this one? I need to make this look like this. No parentheses. What would you do first? Multiply out the parentheses. Yeah. Start doing that. And don't forget, when after you do those 4 multiplications, there's still a plus 2 at the end of it. So 4 times 3x is 12x. 4 times 2 is positive 8. Negative x times 3x is negative 3x squared. Negative x times positive 2 is negative 2x. And after all of that, there's still a plus 2. Parentheses are gone. Now I just have to simplify everything and make sure everything's in the right order? Well, if you notice standard form, there's an x squared term, there's an x term, and then there's a number or a constant at the end. 3 terms. So what would I write first? Well, in this case, it's what though? It's negative 3x squared. Okay, so I've done that. And now the x term. Well, I've got to combine a couple of x's here, which is positive 10x. So that takes care of those. Plus 10. What's the value of A? What's the value of B? What's the value of C? Also 10. Good. And that's standard form. I do much the same thing on my other videos. You know, the ones that you said suck?
I didn't say suck, I said they're sus.
They're sus?
I didn't understand it.
What's sus?
Sus.
Shouldn't you say my videos are another word that begins with S and not that word that you're thinking of? No. But you're on the right track. No. SL.
Play.
Yeah. Anyway, that was just an excuse to drink some of my coffee. Just going off on a tangent there. Tangent, right? Get it? Thank you very much. I'm here all week. Don't forget to tip your waiter or waitress. Okay. So we're going to find that standard form, in some cases, we don't want standard form. Like if we want to graph functions, we want vertex form because it's much easier to work with. However, we do use standard form is better in some other cases that we're going to see in the next unit. Standard vertex form is actually harder. But in this case, if we're stating properties and if we're graphing, we want vertex form. Because just as an example, here's a quadratic function in standard form. Tell me as many properties of it as you can. These are all the properties we did in that example at the beginning. So what's the sort of main property we always like to start with? Vertex. Can you tell me the vertex? No. Which means if you can't tell me the vertex, you can't tell me the axis of symmetry. You can't tell me the max-min value, but you could tell me the max, whether it's maximum or minimum. Right? Why is it maximum? Right. There's a negative at the front. So I know I can say there's a maximum, but I don't know what the value is. Which means, and I've asked you this as well too, it opens down. So that's one thing we can say for sure. There's a maximum and it opens down. Is there anything else you can tell me? Why? What is it? Exactly. Domain, you can always state. But range, I need the vertex. So we can't do it. Yeah, what about the number of x-intercepts? Well, no, because I don't know where the vertex is. I know it opens down. Right. But before we do that, there is one other thing you can tell me. Out of all those things we did. There is one other thing you could figure out. The y-intercept we could do. Because all we have to do is, every time we see an x, Put 0. It's actually pretty easy finding the y-intercept in standard form. It's always the number at the end because everything else becomes 0. So here the y-intercept would be 3. Okay. So obviously, as you said, McKenna, we want it in vertex form. So we need to figure out a way to change from standard form to vertex form. Well, when we did vertex to standard, we multiplied it out and then simplified. So what kind of math do we do when we want to work backwards to see what multiplies to get something? What do we call that when we start with some answer and we're trying to figure out what times what gives you that? You've done tons of it. Okay. Okay. And what did we do with those things? No, but when we went to reverse, when we ran in reverse, like if I gave you an answer and I said, tell me what times what gives you that. What's that called? Like you multiply two things to get an answer. You do what to the answer to get back to what you multiplied? Not divide. We did a whole unit on it last year. We did a whole unit on it last year. Like if I said to you, maybe this might help you. If I said to you, what are you doing to it? Got it. You're factoring. When you take an answer and figure out what times what gives you that answer, that's called factoring.
Yeah.
Well, you're going to have to learn to love it. Okay, so we're working backwards. So it's going to involve factoring.
Oh, well, by non-expression.
Well, you can leave it. It's an example.
Okay. Yes. No, we did these last year. Yeah.
So, no.
Okay.
Sorry,
A perfect square trinomial is a trinomial when factored. Unbelievable.
trinomial comma. Comma.
Equals a binomial times itself. So as an example,
Period.
like you guys have heard of perfect squared numbers. Why is 5 a perfect square? Because it's the same as 5 times itself. Why is 36 a perfect square? Because it's the same as 6 times itself. Right. We're just talking about perfect square expressions now. So if I said this, this is a perfect square trinomial, which means when we factor it, we'll get 2 identical binomials. Remember when we factor these x squared trinomials, 2 sets of parentheses, what goes in the first term of each? X and x. And how do I figure out the numbers again?
Oh no, it's like the Sum of 10, product of 25.
Right. Two numbers that have a sum of positive 10 and a product of 25. 5 and 5. Well, anything times itself,
And parentheses x plus 5 squared.
right. Doesn't that look like part of vertex form?
Yes.
Yes, it does. So we're going to need to do some factoring to change the vertex form. That's what I want you to get out of this. So we're going to have to create some kind of perfect square trinomial that we can factor to make look like this. Yes.
We're going to go from the
Standard form
to that,
to vertex form.
and then what if it's not perfect square?
We have to make one. And that's what this method is called, completing the square. So good question. So, yeah. Yeah, what?
So we're going to vertex standard. You can just do that.
You multiply it out.
But if you're going from standard to vertex,
You have to do some factoring.
But
You'll get this. We have, you guys, we haven't even done an example yet. Okay, here's what we do. Okay. Like, first of all, look at this. Could I factor this? Two numbers that add to positive 8 and multiply to 5.
no.
Wait. Two numbers that multiply.
No. Add to 8, multiply with 5. I don't think so.
No numbers multiply to 5.
Okay? So you can't do it. So I need to put in a number where I can do it. Okay? And here's how you find that number. First of all, I'm going to separate that plus 5. And what I'm going to do is I'm going to make a trinomial that I can factor. So I'm going to put in a number here so that when I factor it, I get this. The question is, what number do I put in?
That's really hard.
Yeah.
Okay, remain calm. Look at this example. Okay? Notice that if it was x squared plus 10x, I need 25, right? In order to do this. Can you see a relationship between how I could use these two numbers to figure out that 5 is the answer? Anything that I could do to 10 and then get 25. What could you do to 10 to get 25? This is a challenging question. I don't understand what 24, what you mean. Yeah, this is a challenging one. To figure out what this number is, okay, I would take half of this. Okay, so I'm going to take 4.
That's what I said.
But what do I do to 4? Or sorry, here, if I take half of this, I get 5, right? What do I do to 5 to get 25? Times it by itself. Excellent. So to figure out what this number is, you take half the x term and times it by itself. 16. So to get from there to there, you take half of 8 squared. You just created a trinomial that you can factor to two identical binomials. However, I've added 16 to this expression, haven't I? I've changed it. What could I do to balance it out if I've added 16? Subtract 16. So what we do, and ladies, this is the first one we're doing. I need to add 16 in order to factor. But if I'm going to add 16 to it to keep the value of the equation the same, I got to subtract 16. Okay? And notice now that I've separated off the first three terms because that's what I'm going to factor. So let's factor it. What do you get? Positive or negative? Okay. Okay. And I still have a minus 16 and a plus 5 at the end. Yeah, I can put them together and make minus 11.
Wow.
And isn't anything times itself the same as that thing squared? Vertex form.
Wow.
Boom.
That was like 800 million steps.
Really? I see 3.
Felt like
Okay. So what we need to do is we need to add and subtract a number so we can factor it to get it into vertex form. Let's practice with a couple of more. Yes. No, actually, you're using x squared trinomial. In these questions, yes. All the time. There's no other type of factoring. You're not doing GCF. You're not doing difference of squares. That's a good question. Okay. So here, in this question, we're asked to state the vertex and the equation of the axis of symmetry. Well, in order to do that, we got to get it into vertex form. So, first thing is write the x squared and x terms in the question together. Put the number a little ways towards the right, because we're going to fill this in with two numbers.
Yeah, why are we showing all this? Because we need a factor.
What number am I going to add and subtract? How do we figure out that number? Half of this squared. Half of negative 10 is negative 5. Negative 5 squared is positive 25. So we do half of negative 10 squared. And I get positive 25. The first number will always be adding plus. So if I'm going to add 25 to this, what do I do to keep it balanced? Minus 25. Well, now I put this off and factor it, because I needed the trinomial in order to factor it. So what do we get?
well, we need negative 5 and a positive 5.
Really? Don't they have to be identical?
So let's put it
Two numbers that add to negative 10 multiply to positive 25. Negative 5 and negative 5. Yes, they have to be the same because I have to write it as squared. They have to be the same. And then this, negative 26. Now, the final step is take the two identical binomials and make a squared out of them. and we've got vertex formed. Many students will skip this step, and that's okay. Like they will say, okay, I know they're going to be identical, so if I just figure out one, then all I have to do is write that one squared.
Wait, can we do that?
No, absolutely, you can do this. Okay? I'm putting this in there to show you how we're getting it. Many students will just go from here, they'll be able to go directly to here, and that's fine too. Either way is fine. Okay? Don't be a hero. There's no bonus marks for skipping a step. Okay? Anyway, we still have to answer the question. Now, what's the vertex?
Vertex. I don't know.
I didn't even look at you. I was looking at the board.
Yes, I did.
Anyway, that's the vertex, which means you can tell me the axis of symmetry. And I just usually put A of S. X equals 5. Good. Okay, I want to do one more example. I think, yeah, we'll have time for one more. We won't be able to finish this because I want to take our time with it. What's different about this one as opposed to the previous two? What's different that's maybe, yeah, there's a negative there. I can't complete the square if it's a negative x squared. I need just x squared. Okay, so, well, I'm not sure what you mean by that. So what we're going to do is we're going to factor out the negative. We're going to divide. So what we're going to do is we're going to take, first of all, that number at the end just goes over to the right. Okay. Now I am going to factor out a negative or divide each of these by -1. What is negative x squared divide -1? Positive x squared. And I need parentheses. Hang on. What is positive 2x divide -1? Minus 2x. Okay. These two mean the same thing. All I've done is I've divided a -1 out of both of these. Okay, so that's all I've done. Why did I do that? Because I want x squared. I don't want negative x squared. So now look inside the parentheses and complete the square. So what do I add and subtract? Half of -2 squared gives me +1. And if I'm going to add 1 to it, I got to subtract 1. Now, I've already opened a set of parentheses, haven't I? So everything that I've done is still in the parentheses. So I can't close it off here because this was part of what I did in parentheses. I have to close it off after this. Okay? That's going to make a difference. I only want these three, don't I, to factor? I need to get this out of the parentheses. So I need to bounce this out here. Just relax. So I need to take a -1 out, right? But what's in front? So if I'm taking a -1 out and there's a negative applying to it, it becomes +1 when I take it out.
But on the other side of the 5.
So now this is gone. Well, it could be in front of the 5. It doesn't matter. Okay, this is a little bit, just relax, ladies. We're all good here. This is the first type of this example we're doing. So we had to do a little bit of extra work if there was something in front of the x squared. Don't worry, you'll practice with it, you'll get it. So now I've bounced this out here, and I've just got this inside to factor. So negative, now let's factor. There's still a negative outside there, because you can see it at the beginning. That was only taking this out. There's still everything else left inside. Okay, good. What is this factor? Remember, the numbers have to be identical. -1 and -1. -4. Okay, one more step. Put the x -1s together with the squared. -4, and we've got ourselves vertex form. So I want to finish this now. I've changed my mind because you guys aren't here tomorrow. And I'm going to give tomorrow as a work period. Okay? So I want to get this last one done so that you see it. Okay. This one. One more. We finished it. Okay. F of x. Remember, take the number in the original, toss it off to the right. It's not part of the completed the square. Now, remember, I want x squared, so I've got to divide out a 2, don't I? So I've got to take out a 2 out of both of these. So 2x squared divide 2. 2x squared divide 2. 2x squared divide 2. X squared. You never said that. You said x. Yeah. 4x divide 2. Okay, so now look inside the parentheses and let's complete the square. What do I add and subtract? Half of 2 and then square it. Be confident, be confident. Plus or minus? So if I add a +1, then what? Then I need a -1, and then I close it off. But I got to bounce that -1 out. Okay? So to bounce that -1 out, in order to take it out, don't I have to multiply it by 2? So to take it out of here, I got to multiply it by 2. So -1 times 2 gives me -2. That's what goes outside. Yes. We've been doing that every example to keep it balanced. If you add 1 to something, to keep it balanced, you got to take away 1. Okay, so let's wrap this up. Don't forget, there's still a 2 in front. Now we're going to factor the trinomial, and -4 minus 2 becomes, at the end, -6. X plus 1. X plus 1.
-6.
And therefore, we can write the 2x plus 1s as x plus 1 squared minus 6, and we've got ourselves vertex form.
Wow, I get
What's the vertex? -1, -6. Does this open up or down?
It opens up.
Okay. What's the equation of the axis of symmetry? X equals -1. What's the domain? Good. Okay. All right. Good job.
Wow, perfect timing.
That was a whole hour.
Yeah, that's the big chunk of the unit.